In this module, we'll cover the topic of single store's procedural SQL, which is essentially a family of tools available to you that captures custom programmatic logic within SQL. So to begin, we'll introduce the concept of procedural SQL and why it's important, and as it always is with SQL, syntax, keywords, and how you structure your code is important, so we'll cover some procedural syntax as well as control flow. And what I mean by that is using programmatic tools like loops and conditional statements to control your code. And the procedural extensions we'll be covering are user-defined functions, or UDFs, stored procedures, table value functions, or TVFs, and user-defined aggregate functions. So if you've worked with procedural SQL before in other systems, the mechanisms in place with single store's procedural SQL should be familiar. But even if you haven't, procedural SQL can still feel familiar if you've worked in any programmatic language like Java or Python. In essence, we're capturing logic in callable functions, and similar to those programmatic languages, we'll define the function name, parameters, scope variables, declare return types, and execute logic with loops and conditional statements. But maybe you're asking why? Why would I write programmatic logic in embedded SQL when I could write my programmatic logic with a familiar language and just let SQL deal with SQL? And the philosophy of that question may differ from shop to shop, but there are some undeniable benefits to having tools like procedural SQL at your disposal. For example, there's a general impedance mismatch between databases and programmatic languages where we need to be concerned with type conversions and extra code for handling other various differences. There's also the idea that your SQL code and your Java or Python code live on different servers, so a query may need to make several round trips, which can perhaps affect the query performance. And speaking of performance, it's important to note that all single store's procedural extensions are compiled directly to machine code, meaning that all subsequent executions of that function or procedure won't need to be interpreted again and again.